Alright, welcome back. It's Mr. Hussein, and we're going to continue with lecture 1 of Physics 101, the basic physics. Alright, so now we're going to look at how we can prove if the left is equal to the right. Literally like what we're doing from the previous video, and now in this video. So let's see what we can do. Saying each of the following equations was given by a student during an examination, which means the question was literally in this case incomplete. So here what they're actually asking us to do is to show if the equations are dimensionally what? Correct. Alright, wonderful. Let's pick A. So remember, to know if the equation is dimensionally correct, you have half mv squared is equal to half m initial squared plus root of m g h. So prove if the left is equal to the right. Then if that condition is true, then the equation is correct. But if the left is not equal to the right, then the dimensions are incorrect. So let's start with the left hand side. The left hand side has half mv squared. Initially in the first video I did make mention that if you see numbers, forget about them. So this bad boy disappears and you just have mv squared. Now what is m? M is literally the mass. So what are the dimensions of mass? Capital letter what? M. Okay, so now just write that down. What is v? V is equal to the velocity, isn't it? Velocity is meters per second, which can also be written as meters over what? Seconds. In form of dimensions, I can write meters, capital letter L, and the seconds, capital letter T, because they represent time, like that. So I've written m, come back here, I have m, capital letter M for the mass, and now I can write for my velocity. So I'll say capital letter L over capital letter T, then a lot of this squared. So these are my dimensions for the left hand side. Alright, let's push to the right hand side. Alright, right hand side has half mv initial squared plus square root mgh. You know, sometimes before you even finish solving, you can even know that this is not correct. Yeah, so I have a feeling that this is dimensionally incorrect because the right hand side doesn't really make me vibe with the left hand side. But anyway, you see where it can take us. Remember, numbers should not be available. So you have mv initial squared plus root of mgh. Alright, so now mass, put a capital letter what? M. Remember, v is the velocity, meters, so L over seconds, so T, the root of this squared plus, okay, the root of that. Alright, what is m? M is what? Mass, capital letter M. Wow, what is g? G is gravity. Let me take you back. Remember, g is remember in books you would find the 10 newtons per kg symbol. Some would say gravity is equal to 9.81 newtons per watt kg. Very simple to understand, isn't it? Alright, so now our interest is this guy here, newtons per kg. So this implies that gravity is equivalent to newtons per kg, which is the same as newtons over what? Kg. But newtons represent force and kg represents a mass. Dimensions of mass, capital letter what? M. What is the dimension of a newton? For now, let's just put capital letter what? F. But if we want, we can also find the dimensions of what? Force. And you can plug it there. But we can maintain it like that because within force, we have inside dimensions. Alright, so we can just say capital letter F over capital letter M. Then we have height, which is L, like that. Isn't it? Yes, wonderful. Alright, so before I even conclude, let me just write a data for my force. Remember, force is equal to mass times what? Acceleration. So which means the force is equal to mass, which is kilograms, dot meters per second what? Squared. Which means force is equal to mass times what? Length over time squared. Wonderful. This is very, very beautiful. Alright, so which implies that now my final answer will be m, then the root of this will be L over T squared plus, get a root of this, get a root of m, I get my force, which is now m, which is with L. Alright, then I have T, again at the bottom I have m, the T, remember, should be squared, then I have L. Even if I did my luck in falling this out, the best chances, this will still not be the same. So if I cancel this with that, I end up having this. So it's just a matter of showing the examiner that you know what you're talking about. But as we can see visually, these dimensions will not be the same. I'm remaining with one of the masses. Alright, then we get the time. Square, boom. Alright, so as you can see, the right hand side has nothing similar with the left hand side. Look at the left hand side. Sorry, not this is not the left hand side. The left hand side is here, sorry. So look at the left hand side, this guy here. This one has nothing similar with this one here. So you can say, okay, therefore these are dimensionally incorrect. Yeah. Alright, so I believe you now know what to do here. Just try and see if you can find the left is equivalent to the right. So in B, you have velocity is equal to the initial velocity plus acceleration, then T, which is the time squared, then C is equal to mass times acceleration is equal to V squared. So A and B will be what? Task. Yeah, so I need the answers. Yeah, but the only hints I can give you are these. Okay, hints. If you need them, that is, velocity is equal to meters per second. These are the units. Then acceleration, meters per second squared. Then you know m is a mass, so it's kg. And what else? Oh, v initial is just the velocity. It's equal to that same thing. Alright, so I think you can pick it up from here. Yeah. So try and prove if these dimensions are correct, or if this is dimensionally correct as well, or incorrect. Alright, this is Mr. Hussein. Kindly like and subscribe to the channel. For the just food for thoughts for the questions in the tutorial sheets that I know and feel like you guys are aware of them, and I've already explained the concept in the previous video. I'll be perusing a bit fast, like this one. If you look at this question, it's like a part of question 2, because question 2 was also involving you showing if something is dimensionally correct, and it's basically what we're just from doing right now. So let's put that in mind. All right.